Hello. Now, continuing our work in independent events, we're going to have a look at question 13. And question 13 is a very good question for showing you the different ways that they can use language in our exam questions. So a fair dice is thrown 3 times. Find the probability that there will be, part 1, no sixes. So no sixes. First of all, I'm going to set up my situation. So in part 1, 2 and 3 I'm talking about getting a 6 or not getting a 6 all the time, so I'm going to write this down. Probability of a 6 is going to be 1/6, and the probability of that not happening, which I'm going to write as PN for not a 6, would be 5/6. So I've set this up now. I have effectively a success or a failure. Do I get a 6 or do I not get a 6? This is going to be important as we move forward. Now, part 1, no sixes. So what meets that description? No sixes. We roll the dice 3 times and we get no sixes. Well, that can only be met one way. We could get not a 6, not a 6, not a 6. It's the only way that we can end up with that situation. So writing it out pedantically, we would have probability of not a 6 by probability of not a 6 by probability of not a 6. So it would be 5/6 multiplied by probability of not a 6 multiplied by probability of not a 6. When you put that in your calculator, you get 125 out of 216. So the probability of getting no sixes at all is going to be probability of not a 6 multiplied by not a 6 multiplied by not a 6. This is fairly straightforward, probably what we expected. Now, part 2 is where things get a little bit more interesting in terms of the language. So we see a phrase that we should recognize. We have talked about it before multiple times. We're asked for the probability of at least 1/6. Probability of at least 1/6. This phrase should be burned into your mind. If you see at least 1, it's going to mean what we're going to do in a minute. But for the beginning, I'm going to pretend that I haven't told you about this, and we're going to go about this question naively. So, probability of at least 1/6 would be the probability of getting 1/6, or, my apologies, probability of getting 1/6 or probability of getting 2/6, 2 6s even, or the probability of getting 3 6s. Now, here's where things get tricky. What are the ways that we can get 1/6? Well, we could get a 6 the first time and not get it the next 2 times. Or we could get no 6s the first, or not a 6 the first time, get a 6 the second time and not get a 6 the third time. Or we could get not a 6 the first time, not a 6 the second time, and a 6 the third time. That was all dealing with this situation here. So those are the 3 different ways that we could get 1/6 when we roll our die 3 times. Or, now we're dealing with probability of getting 2 6s. We could get a 6, and not a 6. Or a 6, not a 6, 6. Or we could get not a 6, and a 6. That was dealing with this situation here where we got 2 6s, so you can see the different ways that we could get 2 6s, or we could get 3 6s. Well, what are the different ways that we can get 3 6s? Well, we can get a 6 and a 6 and a 6. So thankfully this one doesn't have so many options to it. Now we know what all of these things means. This probability here would be probability of 1/6 by the probability of 5/6 by the probability of 5/6 plus, so we're working from here, probability of a sixth by 5/6 by 5/6 plus probability of 5/6 by 1/6 by 5/6. You can see where this is going. Now, I am not going to write all of this out. I think this makes the point of why I have been stressing the meaning of the word or phrase at least one of something, because you can see this will take a long time to write out in full and get your answer. Now, to be clear, if you forget how to deal with at least one in the exam and you write things out as I have been here, you will get full marks. It just takes quite a long time, and it requires you to be very careful of not making a mistake with writing out all of these fairly repetitive things over and over and over again. So this is one way to do it. You can, as an exercise, go through this process and you will find that you get the same answer as we're going to get using another method. But we're going to draw a line under that and we're going to say there is a better way, because we remember, hopefully, the probability of getting at least one of something, 1/6, is equal to 1 minus the probability of getting no 6s. Now, hopefully we're all happy with the logic of that. 1 is the total probability of all of our different outcomes added up. So we can either get at least 1/6 or we could get no 6. They're opposites of each other. So either this happens or this happens. So that means if we added probability of getting no 6s to the probability of getting at least 1/6, we've covered every possible outcome, so that would have to add up to 1. So we've looked at this formula in a few different settings several times in this chapter, and it's very important. If we see at least one of something, this is most of the time what we're going to need to do to make the question simpler. Again, perfectly valid way of doing it. You'll get full marks for it so long as you don't make a mistake, but you can see how repetitive these get and how long this would take to write out in full. So instead, we're going to have equals 1 minus probability of no 6s would be probability of no, multiplied by a probability of no 6s multiplied by probability of no 6s. Far easier to deal with than all of this mess. And it gets 1 minus 5/6 by 5/6 by 5/6. I have it already done out here, but I am writing it out in full so you will have a full example. 1 minus 125 all over 216. And when you put that into your calculator, you get 91 all over 216. So that is the better way to do this question, and we do it that way because we remember that at least 1/6 is the same as 1, our total probability, minus the probability of getting no 6s at all. So this is much faster and less likely to make a mistake than using this method here. Though again, if you panic in the exam and can't remember this, you get full marks for using this method. It just takes longer. Now, let's have a look at part 3. Probability of getting exactly 1/6. Exactly 1/6. This is a lot more restrictive than this is. So that would be equal to the probability of getting, what could we have? We could have a 6 the first time and then not get a 6, not get a 6, or probability of not getting a 6, then getting a 6th, then not getting a 6th, or we could get not a 6th, not a 6th, and then get a 6th on our final throw of the dice. And those are the 3 different ways that we could meet that criteria. So that would be 1/6 by 5/6 by 5/6 plus 5/6 by 1/6. Again, this is coming from here, by 5/6 plus 5/6 by 5/6 by, my apologies, 1/6. You add all of that up as we have been doing and you get 25 out of 72. Again, do that on your calculator. You can see that these will give identical numbers, so you could just multiply one of these by 3, but be careful in more complicated questions, that might not work out quite as neatly. But if you can see that everything's repeated 3 times, then you're just going to multiply by 3. Now, the unmarked fourth part, we're back to probability questions not being laid out very well, and this is mirrored in the exam, so be careful of it. Final part of this question is unlabeled, but find also the probability that the 3 throws all show the same number. Now this is a lot more subtle than it may appear. They must show the same number. Probability of same number. Now that would be equal to probability of any number, so we could get 1, 2, 3, 4, 5 or 6 for our first number. So if we're rolling our die, play this out in your head, we'd have probability of getting any number could be our first number. Probability of getting any number is our first number. And then after getting that first number, and we don't care which one that is, we have to get the same number 2 more times. So the same as the first. And then we have to get the same as the first again. So this is the subtlety that we have to spot, that for the first number we roll, we don't actually care which one we get, because all we're interested in is getting the same number 3 times. So we get any number we like the first time for our first throw of the dice, and then the next 2 have to be the same as that. So what's our probability? That's going to be 1, because we do not care what number we get first. So we definitely are going to get a number first. It could be 1, 2, 3, 4, 5 or 6, and we don't mind which. So that's going to be a probability of 1. We'll definitely get an outcome the first time. We'll definitely get a number the first time. But then we have to get the same number the second time. So that's going to be a probability of a 6th. We've got a 1 in 6 shot of getting the same number the second time. And we also have a 1 in 6 shot of getting the same number the third time. So when we put that in our calculators, we get 1 out of 36. So this hopefully gives you an indication of where the challenge comes in a probability question. It's just getting used to the English of, I see at least one of something, or I see exactly one of something, or I am asked about the same number, and we have to be careful about the subtlety of what's actually implied in those simple sounding questions. But there are relatively few phrases they use, and we will get used to them with practice.